Welcome to homework.
All right, we have got the following compound, and I'm just going to write Me for the methyl group there, and we need to create this compound. So we're given several options on different reaction pathways that may or may not lead to this product. Any one of these pathways is going to give us a diol. But the question is, will the stereochemistry be correct for that diol? So we're told that we want to make this product plus the enantiomer. So I think what would be a good idea then is to figure out what is the stereochemistry of this product. So on the left, it's pretty easy for us because we've already got hydrogen in the back. We can say this is highest priority, second highest priority, third highest priority. That's clockwise. So this is R. All right, so we've got R on the left, and on the right, we've got hydrogen in the front, which means whatever, if we ignore that fact and say 1, 2, 3, that's counterclockwise, but since hydrogen is in the front instead of the back, that means this is also R, right? It looks like S, but hydrogen's in the front, so it's the opposite of that. So we've got RR, which means the enantiomer is SS. Okay, so we need to take this and get us a diol that's RR or SS, right? If we make RS or if we make SR, that's no good. Okay, so let's redraw this, but I'm going to simplify things here. I'm going to put a methyl group on one side and just an R group on the other side to represent the cyclopentane. It's just no use drawing it over and over and over again. So consider that pathway A is sodium and liquid ammonia, right? This is going to give us an alkene, specifically, it will give us the trans alkene, right? So methyl and R. And then the next step is osmium tetroxide, followed with basically an acidic workup. And when you use osmium tetroxide, the diol will always, or the alcohols will always be added syn. That is, we could just redraw the same structure as an alkane, and then if we make a wedge to OH here, we know there's a wedge to OH here. Right, so that's how it will be added. And we'll draw in the hydrogens that we already had. Right, and now we know this is the R group, the cyclopentane, this is the methyl. Is this RR or SS? Well, we can number them like, let's call that 1. We know that's the highest priority. The second priority, highest priority is over there with the oxygen. And then 3, that looks like counterclockwise, so that's an S. Right? We got hydrogen in the background. And then we go 1, 2, 3. Counterclockwise, that's S. So this A is going to give us RS, right? And that is not RR, and its enantiomer is just SR, so its enantiomer is incorrect. So A is no good. It can't be A, it also can't be D, and it can't be E. So we'll continue onward, and we'll look at B. Now B, we start with our same compound, as per usual. And the first thing we do is H2 and Lindlar's catalyst, which will give us a syn alkyne, or alkene. H2, Lindlar's, we'll just put an L. So we're going to get this, and we've got methyl and R on the same side. And then we're going to use MCPBA, which will convert this into a epoxide, right? And then we're going to add acidic water, which means that water is going to come in and attack the back side of one of these, right? And then that's going to go up on there. There's some more proton transfer steps, but that's the long and short of it. So when we redraw this, we have a wedge to our original O, which is now an OH after, once again, this proton transfer steps, dash to hydrogen. And then this will be a dash to OH with a wedge to hydrogen. Okay, is this RR or SS? Let's check. 1, 2, 3. That looks like clockwise. So this is R on this side. And then we go 1, 2, 3. That's counterclockwise. Remember, the hydrogen's in front. Right, hydrogen in front. So that means it's actually R, even though it's clockwise. So this is RR. And if we drew the enantiomer, which would just mean that when we drew our epoxide, we would have had to add to the bottom face, it would be SS. Right. So B is perfectly valid. Great. What about C? Well, we can just basically assume that C is not going to be good because we don't have an option that's C and B, but let's double check. Okay. You could probably stop watching right now if you aren't curious about this. Okay. So we've got H2 and another poison catalyst, nickel boron, nickel boride, which again will give us an alkene. And again, it's going to give us a cis alkene, RN. Methyl, and then we're going to use potassium permanganate, sodium hydroxide, which will add OHs, but it will add them syn, so that's going to give us the following. Got an R down here, a methyl here, and then we'll have a wedge to OH here, and a wedge to OH here. Well, we can already tell just by looking at what RR looked like that this is going to be R still on the left, but it's going to be S on the right. Right? If you step through it, it's. We could just 1, 2, 3. That's R, and 1, 2, 3. That's S, and that's no good. We need RR or SS. So it's B, which is paradoxically answer C. Okay. Right, it's pathway B, but when you go to, it's just to avoid any confusion, it's this one.